Welcome students. Today we'll be start learning about the moment of inertia of a circle or a circular lamina. Okay. So moment of inertia or second moment of area is given as area into perpendicular distance square. Okay. Now we'll understand with the figure at first. We'll draw the figure. This is the figure which is representing the circle of radius r. The x-axis and y-axis are shown here. We take the strip of the circle at a radius of x of thickness dx. I repeat, we'll consider a circle of radius r. Consider an elementary strip of thickness dx at a distance of x from the center. Okay, students? Now we'll continue with the same lines. First thing, choose an elementary strip of thickness dx at a distance x from the center of the circle. Area of the strip will be given as what? Area of the strip is circumference area 2 pi r. Here it is, instead of r, it is 2 pi x. What is the thickness? Dx. So which becomes as a area. This becomes as a area of the elementary strip. So area of the elementary strip. Now I am supposed to take the moment of inertia. But here one thing you should keep in mind, students, for the circle we are doing at starting calculating the moment of inertia about IZZ. Okay, because I don't find any dimensions along x-axis or y-axis. It is r and x, the radius. The radius is taken along zz axis. Okay, so the moment of inertia, right, will be taken about the center. It's taken as in the area of this lamina into the square the distance. To the square the distance. This is the distance. So you find 2 pi dx into x square Now similarly, if I find number of rectangular lamina. So what should I do? I should integrate from 0 to r. The limits of x varies from 0 to r. So further I can take it as Iz is equal to 0 to r. 0 to r 2 pi x cube into dx or on further integration I get it as 2 pi into x to the power of 4 by 4. So which I can show it here. Moment of inertia IZZ about the center or about the center of the circle is equal to area into square the perpendicular distance. So area we have found area into square the one. So area, how to measure? I have to take the integration 0 to r into the area. Area is 2 pi. When I multiply area and the square the distance, it will be 2 pi x cube. 2 pi x cube into dx. 2 pi x cube into dx. Now applying the integration limits and calculating the value, you will end up with 2 pi r to the power of 4 by 2. Okay, but I want the value about xx and yy. I am supposed to calculate ixx and iyy. How to calculate now? How to relate? So we know that Ixx, sorry, Izz is equal to Ixx plus Iyy with the relation polar moment of inertia using perpendicular axis theorem. Sorry, yeah. So wherein due to symmetry in nature, we find this Ixx is equal to Iyy. Why so? Because symmetry. Because of symmetry. Okay, so Ixx, Izz is equal to, I can put it as 2Ixx or Ixx 2Ixx equals Izz or Ixx is equal to, I can put it as pi r to the power of 4 by 4 into the 2 into 2, which will be equal to pi r to the power of 4 by 4. So which is nothing but Ixx equals pi r to the power of 4 by 4. Okay, but Ixx equals Iyy, we are mentioning that here. So which is equal to Iyy. Okay, students, is this clear? So now we have to draw the table indicating the moment of inertia of all the lamina. Something like this. We have the lamina Ixx value and Iyy value. Okay, students. Okay, with this